Really good.
Okay, we're on. Okay, ready, guys?
Welcome to the 4th class people. Or 5th class.
But
we
you
don't
know what? I
100%.
think to do a class 5 o'clock is the best for everyone.
100%.
It's such a good
Yep.
time. 8 is so bad.
On the time?
8 o'clock, class 8 o'clock is really bad.
It's not done on purpose.
I know. I'm just saying, like, no, let's on the sequel 9 o'clock.
Yeah,
It's 5:30 in the
Okay.
morning, guys. We have a class.
Come on.
Okay, guys, ready? Here we go.
Slowly, come on. It's too late.
And where's my
I
notes?
can't get too much pizza. I got diarrhea in the mouth.
Okay, here we go. Guys, ready?
Yeah.
Variables come in 2 flavors. Primitive and object reference. Those are 2 types of variables. That is it, nothing more, nothing less.
What?
There's 2 types of variables, primitive and object reference. Okay, what is a primitive variable? It holds the actual information. So, for example, say we have over here.
I want to tell you what you said.
Say we have over here. Say it's called. We make an integer, and we'll call it x, and we'll assign it 34. Okay.
It just holds the information that integer x equals 34.
Yes, you'll see actually be a bucket.
So why you need?
Actual bucket. That's an integer. Right? It's an integer. It's called x, and inside the bucket is 34.
This is a primitive.
This is a primitive variable type.
So when
I get it.
in x equals to something, it's whatever you say.
What time? It's a primitive.
It's a primitive if it's equal to something.
No, it's
If it's
any
whole
integer.
something, so
Any integer is a primitive variable.
Oh, any integer is a primitive variable, or it holds
Yes.
a primitive variable.
Well, if you make a variable that's an integer, that's what you're doing. Not
Anytime that you're naming something else, you're putting in that bucket.
with integer.
Integer.
integer. So
Integer
it's
is a variable.
not only integer. Integer is one of the primitive
Right, so what I'm
variables.
saying is if it was a substring and you put the substring into the, and called it substring par, then that substring will still be the same exact case. Substring would be the, substring par would be that, and then you put, I don't know, the name Jaguar instead of something.
Yeah, I mean, I think you're going way too complicated. It's just you save a string, you put it in there, that'll be in there. But actually, let's hold up. String is actually not so simple. So let's get back to
Can
it.
you go back to the other to your? Can you go back?
So,
Okay.
Yeah, what's your question?
In simple terms, a primitive variable is a
A bucket where the actual value that you assign it goes into that bucket.
So it's basically just somewhere where it's basically something that holds a value.
Yeah, and this is okay. This sounds simple, and it does simple. The reason why we have to talk about primitive variables because it's very different than object reference variables. Okay,
You know the book really good.
amazing book. So what's object reference variables? Object reference variables are variables that don't hold information. They just point to somewhere else. Okay.
I start to see bad.
Okay. So you look over here. Let's first talk about primitive. Let's talk about primitive variables first. Okay. These are all the. There are in total. Here's all the primitive variables. There's 1, 2, 3, 4, 5, 6. There's 1, 2, 3, 4. There's 8 primitive variable types.
You don't have to memorize it. Right?
Can you go up once
That
again?
is it.
Can you go up once again? And object reference. This is the second one.
Yeah. Okay. It says, look at this over here. We're looking at this first column shows the type of variable. The second one shows what you can actually put inside of it. I mean, how much it stores behind the scenes, and the values, what values you can put in there. So let's look at
var card.
one more time.
Where's our var card?
Varkar's only in SQL.
This sucks.
What's var?
That's a SQL type.
Yeah,
Yeah, type.
with var.
Okay, so let's look at some simple ones. Boolean. What is Boolean?
True or false, basically one or the other.
Right. So if we look over here, if we made something that's called
Could be right and wrong.
one more time.
Could be right and wrong or
Yeah,
whatever.
true or false. So say you make one, it's Boolean. Oops, excuse this.
No, can you make it right or wrong instead of being true or false? No, the
Oh,
words.
I don't think so.
I've never seen it.
Yeah. Okay, let's make Boolean. Let's call it y, and we'll call it equals true.
I think I found a mistake in the book. Well, you know.
Okay, so In this scenario, you would have a bucket. Okay, bucket would be a Boolean type. Okay, and it's called y, and inside you would have true. That's what you would have inside there.
Okay.
Okay,
Alright.
let's look at this. How many bits does it take for a byte?
2, no?
8.
No. 8? It's not a vampire. That's 2 bytes.
Okay, so
No,
if you notice,
there's something in
So
SQL.
if you-
You have 2 space on every word and every letter.
No, megabytes.
I don't know. There's something.
so let's go through this right now. Boolean, that can hold true or false. Char can hold 16 bits, right?
Char or char?
Char, however you want to pronounce it.
Yeah.
This should be for characters, so it really should be char. 16 bits, right? Which is 2 bytes. Okay, a byte is 8 bits. So that can have 0 to 65535. That's what it can hold.
Is this in chapter 3? You
Wait,
can
what?
do
It can hold what?
Sorry?
It can hold this value to this value.
65525.
Every bit holds approximately how many numbers?
A bit? 1 bit? Well, it doesn't work that simply because
So it's not a 16?
one time. Look over here.
535 is not a 16?
Look over here. You see over here, if we use the smallest variable, which is a byte, right? Which holds 8 bits, you can have from minus 128 to 127.
What is it? Value?
I'm
What is
so-
the value?
Oh, so it works also by tenth by space. So like tenths.
Yeah, I wouldn't get. I mean,
I'm kind of confused by
Why?
it, but well,
okay. Let's look. For
like,
example,
what do you mean by a byte holds like one?
okay, if I go over here and I go byte, I'm making a byte thing. Let's call it z, and I do equals 129. That would not work because the number 129 does not fit inside
Yeah,
a
but why
byte.
does it go to 127? Why can't it just be like a it doesn't. I don't see like the pattern basically.
Okay, the pattern don't get. I can explain it to you now, but you're going into computer science now. It has to do with the fact of how bytes work. This is 1, right? Let's go here. This is 0, right? What's 1? This is 1. Okay, make it 1.
Okay.
What is 2? 1, 0. What is 3? 1, 1. What is 4? 1, 0, 1. What is 5? 1, 1, 0.
Okay.
What is 6? 1, 1, 1. So there's only, in a byte, all you have is 8 bits. In other words, you have 8 boxes to use. 1, 2, 3, 4, 5, 6. 1,
It's
2,
really important to learn those stuff.
Okay? If you use these numbers, if you fill all these up, all you will get is to 127. Or minus 127. That's the only thing it can be
So
represented.
if you're talking about all the ones or all the zeros?
It's basically how many
the
times.
one
options.
represents a number. Like 111 is the number 3. Yeah? No, the number 4.
No, here, I
4.
think I think
5, no, more than that.
You have 16 spaces.
You don't have to worry about this. This is-
Combinations if you can of those ones and zeros in there.
Oh, it's 120. Okay, I got it.
Yeah, this is
127.
it's really 127. It's a little more. It's 127 plus 127. You know, we're talking about 204 and 54,
Right.
55. But they, instead of doing 0 to 55, they represent some as minus. So you have 127 minus 127.
So the 65535 on here, which is a short 16-bit, that just means it's still 65535, except it's
Why are you-
minus
what you looking at?
32768.
This one?
Plus, yeah. So that will equal, go to the bottom 3 down, where it's a short 16-bit.
1 second. Where this do?
You can make it 6555 space.
Picture yourself.
Okay. What'd you say?
Okay. You see where it says short 16-bit?
Yeah.
Okay. So if I were to take short 16-bit, it says 32768 32767,
Right.
right? But if you split that and you plus that, it'll equal 65535.
Oh,
It's still
that's
technically that amount.
so you're 100% right. In other words, they both store 16 bits, but over here you can actually go to negative numbers,
Right.
and over here they put it into positive numbers.
So basically, with character, it can only be there's no decimals.
No, decimal you use the double.
Or I'm saying there's no negatives.
No negatives. Yeah, that's correct. Okay.
So wait, if you wanted to represent a decimal, you couldn't do integer x equals 12.6. You would
You
have
can.
to do,
Integer by definition means there is no
There's no decimal.
decimal.
so you would have to do double x equals
Yeah.
64.7.
Yes,
let's say.
100%.
If it finishes, they're saying long, it just means forever.
One time. Where are you?
It says int 32 bits. What does it mean long?
21, 4, 7.
I don't know what you mean by that, but that's
4, 7.
yeah. What about
What
that?
is long?
Thing
Yeah.
long,
I know that.
digits long.
I mean, that's how many digits long.
Okay, it could be so. And over here the huge to huge. In other words, if you're using
What is something called 64?
a second. That is
Yeah,
not right.
64 equals
No, that is not right.
64x equals.
Give me a second.
2.
That is not right.
Paradox.
Yeah, it says there. It's so weird. It's a mistake.
What?
X equals 2.
Look at my book. What's this in? It's wrong.
What, 64 bits equals minus huge plus the huge?
Yeah, the book is wrong.
Why, it's not?
There's no such thing as 64 type. That's wrong.
64x. No?
Maybe there is, you just don't use it.
Or maybe they meant to add it by 5, but. that
Yeah,
doesn't
it's
matter,
called long.
but-
That's the mistake. It wrapped around. This long belongs in the
Ah, you wrote it?
No, the book. They see that's the problem. You get these versions for Kindle. When they format it into Kindle, it messes up the formatting.
Let me see if I have that as well.
When
What
you join the
page?
SQL class, SSRS?
Well, what unit is that?
What?
What unit is are you in?
What time?
Oh, never mind.
Ah, you wrote it in Kindle, man? How much is it?
What page are you, what page are you on?
It's beginning of chapter 3. After.
Yep, I got it here. Freaked up. So how do I take this book seriously?
What?
How do I take it seriously?
Well,
It doesn't happen all the time.
yeah, it shouldn't have that much. It shouldn't have that much. If it got that much, you'd have a lot of complaints on these
So is
sites.
that the answer, long? Int, and then long means huge minus huge to huge?
So long, which is 64 bits, means huge to huge, meaning.
I think the 64 is supposed to be where the long and the long supposed to
No,
be
it's
Wait,
where-
I will have an argument for you. If that is true, then why at floating point does it say 64 bits?
What time?
At floating point.
No, 64 is correct, but it's not called 64. It's called long. Look at my screen.
Yeah.
I'm fixing it now.
Two things can have the same amount of bits in it. For
You know-
example,
you know-
car and short both have 16 bits, but look how short has a lot more.
You know, with this software,
You said it like
the same software, you know, with this software, I think my kid
Very
But it-
teaching you well.
Yeah?
If I didn't know you, man.
is so good that I get
Sorry.
accepted to the
Okay, so I'm going to fix this. Okay, that's fixed. Okay? Thanks for catching that. Okay, so you see over here, let's go through. Okay, so green has true or false. You see here's a JVM specific?
Yeah.
Right? Because at the end of the day, each Java virtual machine can decide how they want to
specify.
yeah, what kind of bytes will mean true or false. Okay, let's move on. The point is by primitive is that whatever you put inside the variable, it actually goes inside the variable. Okay. Now, if you're knowing why do we here to say varies? By double it says varies, right? Why is that? We'll see later on. Because basically by double, you can put in massive numbers, and behind the scenes it has to expand how big it is. Okay, let's move on. Okay, so if you look over here, here's an integer, and we do integer x equals 24, right? Okay. Then we do byte b equals x. Okay.
What is the byte?
Now, should that work or not?
No.
Why not?
Because it's in.
Why shouldn't it work?
Because what is byte? I don't remember what is byte.
Byte over here can hold minus 28 to 127.
And in.
And over
all
here,
four.
and here we're saying that it's 24. We're making the byte equal the integer. How come it won't work?
Because they're two. Because one is. Because they're two different types.
Well, close, but not exactly. The reason is because int could hold more. Right? An int can hold to this number, and this only holds to this. So even though at this moment in time this is small, the compiler will say that's not allowed.
Potential. Basically,
Yes.
You never know. Leaving room for no potential.
Here we go. So here, I'll read this line. All the compiler cares about is what you're trying. All the compiler cares about is that you're trying to put a big thing into a small thing, and there's a possibility of spilling. In other words, things spilling out over the top of the bucket. It won't let you do that. However, the opposite you could do. So you could make a byte equals 24 and then assign it to an integer, That's fine, because it can fit into the bucket.
From small to big and big.
Okay? Okay, perfect. Now let's move on to, so you got primitive. We'll discuss object reference in a minute. We got primitive variable types, right? Primitive variable is a bucket, and the actual value goes into the bucket. So x equals 32, 32 goes inside there, and it's an integer. Okay, and the main reason why this works fine is because look over here. You see over here? These are the variable cups, so to speak. They're known off the bat. If I make a byte, the memory in your computer knows, okay, all I need is eight, right? All I need is 8 bytes, is 8 bits. So it's easy, you can make it a thing. But if you make an object, I want to put it inside a variable, memory doesn't know what to do with it, because once I can be this, and you can assign it this, and this can remember, an object can have references to other objects, and get way too messy for memory to manage it. Okay, so that's why it works different. Yeah, we're learning, right now, this type of stuff, to be a beginner programmer, you don't have to know this stuff. But this book is really good. It actually takes you behind the scenes, because when you start working with programs that are running slowly, you're going to need to know this stuff. You know what I mean? You can actually get by this book, the whole chapter. But this book is actually very well done. The people who did it want to educate you in a real way.
Yeah.
That you actually know some really important stuff.
Interesting with that.
Okay, next thing. What could you name a variable? Okay?
What you think?
Right? Here you go. Here's the rules. And this goes for a class, a method, really anything that you're naming in the system. Okay, here we go. It must start with a letter, an underscore, or a dollar sign. That's it. You can't start with a number. Or you can't start with an exclamation point. Okay?
You can't say 90s, you can only say non-90s.
Yeah. That's your variable. Number 2, once you have a first character, then you can use numbers as well. Okay? Number 3, then you can do anything you want except to not use this entire list.
What?
This list of 50 words that Java uses, don't use. In other words,
Can you use
right, I can't go ahead and have
Use it at all?
not for variable names, because the compiler will get totally confused.
Wait, can you use it as class names?
Not class.
What
not
about
reference.
what about Switchfoot?
Can you?
They have a van called Switchfoot.
Where are you? Where do you see that?
Switch.
No. What you put in the variable, anything you want.
No, the name.
The name of the variable you can.
But that's the point. The name of the variable, so I'm naming a band, and the one I'm using is Switchfoot.
But the variable name is just what's holding it. You can put a variable that's called band name inside goes Switchfoot. That's fine.
But that's what it said on top, class method variable.
No, the variable name, not what goes in the variable. Remember, what goes
So
in
the
the
name
variable.
of the class, the name of the method, the name of the variable.
Right, but not
Do
what
not
goes.
have the word switch.
Right.
So I can't call my class, who I'm naming after, the whole thing is about Switchfoot, I can't name it Switchfoot.
Well, Switchfoot is together, so it's fine. It can't be just switch by itself.
Switch. It can be switched.
Okay.
Yeah. See, over here it's 5 by 10, so it's 50 words. And this, by the way, if you look at these words, you'll get basically the Java language. If you want to know what words Java uses to make a language, it's amazing how little it is. It's 50 words.
When you think about it, we have conversations in a day,
Yeah.
you realize it's only 50 words too.
Okay, and most of them are like, if you look at this, Boolean you know already, byte you know already, car you know already, double you know. Most of these you even know already. Some of them you don't. But that's how ingenious it is, these people who create these languages. They take 50 words, and with that, create a language, and the rest do whatever you want. Name anything you want. The compiler just knows these words and some symbols.
And will it find it if you do that?
One time?
If you screw up, will the program
Yeah,
find
yeah.
it? So-
Because it won't. The compiler won't know what to do. If I go like this, if I go to where's my paint board? If I go to here,
So basically what we're learning right now is what those 50 words mean.
that's exactly what it is. 50 words and some symbols, like equals and colon.
You check that.
Well, now I just feel stupid.
That's the most amazing about programming. See, it's not hard if you realize it's just 50 words,
Right.
and then everything else is just playing around
But
with it.
then you try and you realize those 50 words, one word is equal to like
Okay.
6 meanings.
Okay. So Boolean, right?
How come I didn't see like target number there and stuff? That's stuff that you wrote yourself?
One time.
Target number.
That's commands that you make up.
Target number. What's that?
Something that I made up, right?
Anything that you name, maybe you want. Okay, so I go like this. If I have an integer,
Target number equals-
and when I call it integer, the compiler doesn't know what's going on here, right? It sees 2 things in a row. It doesn't know where what to start. That's why you can't do it. But I can call it this integer. I can call it C int, whatever I want, but not int.
He's coming.
Okay, continue. Okay, so now we get into objects. Okay, guys, this is where it gets a little fun. Objects. There is actually no such thing as an object variable.
Thank you.
Okay, so if I have over here, I have make a class, and the class is called dog.
Well, object cannot be a variable because of the simple reason that.
So what is instance
Wait a
variable?
second.
Look, if I over here and then make dog x equals new dog, right? Right? Yes or no?
Yes, there's no object yet.
There is an object.
What?
Over here, I created an object.
Dog.
X is this new dog.
Yes, but it's still not that. Okay, yeah, fine.
Okay, so over here is a bucket called X that's type dog. What's inside here, a dog or not? Answer is
It's a
no.
bucket.
But we have this. There has to be a dog in there somewhere. Where is it? It's not there.
It just calls onto the dog.
So what it's in there, we'll learn soon, is a remote control. Okay, that points to your dog that exists somewhere else in memory.
So it's really that's a reference variable.
That's why it's called the object reference variable.
Yeah.
It references an object. So your dog over here, you have your remote control. Okay, that points to your dog, and when you press a button, it can grab the dog and does something with it. And the reason why it is this case is because objects not usually, can grow to be huge. Imagine an object if you're dealing with so you're making a Minecraft. An object can literally be, terabytes if it's a complicated situation. So when Java wants to be able to deal with memory efficiently, if it knows that variables usually are small, you have integers, okay, deal with one part of memory, and you want to reference these massive things, put in a different part of memory that's meant more efficiently for that. Okay? So why do you have to know this? Let's look a little further. Where's my book? Okay. So there's only an object reference variable. In other words, inside the variable, you have an object reference. It's a remote control that points to the object. Okay? An object reference variable holds bits that represent the way to access an object. What those bits look like? Every single JVM has a different one, so you don't have to know. It makes no difference to you. You'll never need those bits. It'll be like an address. Like, behind the scenes, you'll have over here inside there, it'll be like 0111000 that just references a point in the memory where this dog is.
Right.
Okay, but you'll never need this number because every single Java virtual machine has a different number how they use it. So you don't have to worry about that. Okay. Okay. So here you go. It doesn't hold the object itself. It holds something like a pointer, remote control, or an address, right? Okay. That's a little further. Let's look at this picture. This picture will have you see this picture? Okay. So you have a remote control, right? And on the remote control, that's pointing to this dog. You see the dog symbol here? When you press these buttons on it, there are the methods. It goes to the dog and does it. So say your dog has a thing called bark, right?
So the actual file itself, this is part of OO basically? This is part of object-oriented programming, so when you call on it, when you do reference variable, you say dog x equals new dog, right? Dog is already a class in itself.
Well, okay, at this point, when I say dog x without doing anything else, I'm creating a bucket that is going to hold a dog.
There doesn't have to be a class named dog already.
What time?
There doesn't have to be a class named
There
dog.
has to be.
Of course there has to be a class.
Oh, okay.
Yeah. But if I just do dog x, right,
We'll still create that.
I'll make a bucket that says there will be a dog in here soon. Then when I say equals new dog, boom, puts a dog into the other side of memory and has a remote control connected to that dog with buttons that says like bark,
So if I were to
walk,
talk about
bite.
new dog, right, and then I start using the reference from dog. So dog thinks of size, blah,
Say it again, I
blah,
missed
blah.
it. One more time.
I do size. I point to dog and it says size, color. And
Right, so you're
right?
changing it over here.
No, so that's the same. When I write it underneath, it's actually being changed over there.
Yes.
So now there's 100. So I can put 10,000 dogs in there by writing it here.
No, each dog it needs a different bucket.
No. Right. So,
But whatever
my
you
point
change is changing in here.
So I can put in the long run, I'm putting 10,000 references in there. But
No, only one reference. Any other dog has to be
dog, that's my point. So if I were to put in one program class, so if I do dog x equals new dog, right? Class dog. I don't know. And I put like 3,000 dogs.
You can't. You need 2,000 variables.
No, I understand. I'm
Okay.
done with 3,000 variables.
Okay.
But all those 3,000 variables, you said to create a new dog inside of dog.
Right. So let's make another one. So
My point is there are 3,000 now. Technically, there are 3,000 dogs in dog. Now.
Yeah. So if we,
That's all I'm saying.
so if we over here make another one, dog Y equals new dog. Okay. So you'll have another one here
Another bucket
called
same
Y.
with another remote.
Another remote. Okay. Pointing to there.
Do
Okay.
you randomly generate dogs, or is there like a
Yeah, we'll later on.
like let's say you have like a game, you know, like a dog simulator,
Yeah, 100%.
and like as you walk, there's more and more dogs. It's just
100%.
randomly generated.
100%, we did that already.
No, but that's just random generator. You have
Yeah,
to already
100%.
have those.
Well, you make. What do you
If
mean?
you think about it, you probably do it already.
Right.
Make some
You put
loops
this-
and
Remember we did those things, a bunch of different types.
Right, but
So just do it specific, where it's instead of a bunch of different types, you have a full description of the dog,
okay, and then
and then
From that
it's
description.
random.
Okay, so let's look over here. Okay, so look over here. So if you notice over here, this picture has so much information, which is very nice. Dog, it's saying that this is holding a dog, right? You see this reference over here?
Yeah.
Holding a dog. And these play, fetch, wag, bark, eat are the methods that are on that dog. So when you press wag, it goes to here and wags. Eat, eats. You want to change it eyes to brown, it goes to here and changes eyes to brown. So all you have to think is that these variables hold references, hold remote controls, and you press this, d.bark. Imagine that D is your remote control and bark is a button that says bark. That's the easiest way to visualize it. This book, it made up this concept of remote control. I've never seen this before, and it is amazing. Because I've seen other books try to explain this whole concept, and they failed miserably. So you thank God I got this book. So D is the remote control, right? We called it D. So D now is this variable, right? This dot bark, which you're pushing the button bark, which now is going to that dog that's in memory and barking. Okay? Okay, so let's go back up to here. So look at this last thing. Okay, so it doesn't hold the object itself. The dog is not in that bucket. It holds something like a pointer or an address, which points to a piece in memory of where that object is. Okay? In Java, we don't really know what's inside a reference variable because each virtual machine, remember, virtual machines are created by different people. One Linux makes a virtual machine, so one Java compiles the bytecode and runs on that machine. So each one decides how they use these object pointers. You never need that number. No one will ever. Your boss will never say, "Give me the number of what's those bits, the reference." It's never needed because it means nothing. Okay. Okay. Next thing.
Is that why when you're downloading something, they will ask you for which version, which operating system you have?
Yes, but it's really
each one is like
yeah,
100%. That virtual machine
100%.
that's built on that.
But that's really not good programming. It shouldn't have to do that. It should be able to tell.
JVM, we shouldn't have to worry about that.
But,
No,
JVM is
JVM is different
yeah.
on every computer. So Windows has their own version of the
Yeah.
JVM, Linux has their own version.
Yeah.
And
Yeah, but I
Apple
thought
has
they're all connected.
the
They're
code
all
that
Java.
runs in there can run anywhere because that's like an
Right,
interface. But that's not good. I mean, in general, if you're going onto the site, it should be able to detect what operating system you're on.
Oh, I'm not talking about a site, but I'm talking
Downloading
about.
like a program.
Oh, you're talking about the actual site itself?
Anytime you go to the site that says download a program, it should know. I hate when it says which operating system to choose.
But that's a totally different thing. That's JavaScript and HTML. that
I'm
you
saying
can
they should. If you're any good site, when you're downloading a product, the good ones should never have to ask the operating system. They should be able to detect what computer you're on and what system you're using, and you have it.
I guess for a site like Oracle, you're right, but for like a simple site, you know.
I'm saying it's good programming. Put it that
Right.
way. I hate it when I have to look at my thing on my 64-bit Windows 7, which version. They should know what you're doing already, and it's possible. It's not that hard. Okay, this is what we have to keep in mind. So say we have.
So you should copyright that idea and actually do it because people watch YouTube videos and that.
Well, people do it. I've seen companies that do this.
Yeah?
Yeah. Yeah. If I go, for example, I went to down LastPass right away what I was using. Okay, so say we have. Okay, so say someone's speaking to you in a conversation, but your coworker. He says, "I put a new foo object in my variable named myFoo," right? Right. So let's look at this. This is what he did, right? Foo called myFoo equals new foo, right? So he says to you, I put a new foo object in my variable named my foo. That really, even though it makes sense for a conversation, really is not true.
Right.
You're never putting the object in the variable. You can say that in conversation because it's fine, but really you're putting a reference. You're putting a remote control.
Wow.
The best word is remote control. You never, there's no such thing as putting an object inside a variable.
So
Impossible.
why the same in both instance variable? It's like the object.
The instance variables.
Yeah, it's an object.
Again, this conversation. These,
No, in the book.
you're right because you say it. No one says I'm putting a remote control in there, but that's it. Behind the scenes, you have to understand that.
Okay.
Okay.
I don't understand. Why are you laughing? You're laughing with my language, man. You don't know. What do you know? It's only English. You know, I just know something.
We're just learning about variable.
Okay.
Oh, I know this language. You know, I know.
Okay, so here it is. Okay, so here it is. There aren't expandable cups that can go to the size of each object, right? They have to just make it in a place of memory. Objects live in one place and one place only. The garbage collectible heap. We'll learn about that in the next chapter.
The heap?
The heap is a certain point of memory. We'll learn about it later on. I think in the next chapter after that.
No,
That's where objects are. It's called the heap. Okay, that's all you got to know about that.
They said that on chapter 2.
Yeah? Okay, so...
They said reference it in chapter 4. 4, 5.
Okay, so we got this down, right? So primitives are easy because they just have buckets that are exactly the size of what you define. If I say byte, simple. Make a byte, that's this size of cup. It's like giving you a small cup. But by objects, there's really no size. They can grow and get bigger and change so dynamically and quickly that just puts this part of memory and put it in remote control. Okay?
Pretty cool.
Okay, so now let's, what time is it now? 8:40. Do you have any questions on the other stuff today? I want to look over that first, then we'll go back to this.
Yeah, just real quick, I would love for you to explain the answer to
Let me just pause this.
to foo plus